Okay guys, I'm going to do 5F now. This is what we did during the last class before holiday, so if you were there during that class, you don't need to worry too much about this. It's more so for those that weren't there. I'm not going to edit this video at all either, so you might be able to skip forward or go back to anything that you don't understand or hear properly. That's all good. Alright, so in the past, we've been dealing with heaps of different types of functions and rules, and we've normally had y equals and then whatever our rule is just here. But a couple lessons ago, we had a look at function notation or mapping notation, which is what we see here. So each of these things means something different. So hopefully you remember this is the name of the function, that's the domain, that's the codomain, which you don't need to worry too much about. That's always going to be R, and then you've got the actual rule. So the bit that we're kind of looking at during this lesson is, instead of writing y equals, it's going to be f of x equals now, or g of x, or whatever your name of the function is. So this is what we sort of want to concentrate on just here. Now let's go down to this bit here. I just want to make sure we understand exactly what this means. Now, if you look at this, we've got the name of the function f, and then we have x in there all the time. Now this whole thing here is the same as y. Now if we look down here, we can see how instead of x, it's actually a 2. So what it's saying here is that when our x value is 2, our y value is 6. So this kind of thing that we're seeing here, it's actually a coordinate, which is something you guys have worked with a fair bit before. So we could say that when x is 2, y is 6. They're the exact same thing. We can go down here and do the same. So when x is 1/2, y is -3. So as you can see, or as you can hopefully see, this is reasonably simple. We can just see we've been given an x value and we've been given a y value as well. So I'll finish the last couple off. Cool. So sometimes instead of being given this kind of thing which you're used to, you might be given the same information in this form, but you just need to recognize that they are the exact same thing. So a couple of the questions that we're going to do as part of this exercise, you'll be given the function notation instead. Alright, so let's move up to our first kind of proper question here. Now, what it's saying is we've been given this rule here. It looks like it's linear because we can see x is just to the power of 1. The gradient's b, so we don't know what b is, and the y-intercept is a. We don't know what a is yet either. And it's also told us that when x is 4, y is -1, so that's a point on the line. And we also have another point, which is when x is 8, y is 1. So underneath here, I'm just going to put them as coordinates, maybe to make it a little bit easier or more familiar for you guys. There we go. Now, hopefully we can see that this isn't really anything new. You guys have done this, a whole heap of times before. And I would ask if we were in class, like, what are we actually going to do with these points? So something that I need you to know, and I do keep on saying it, is that if you have two unknowns and they give you 2 points, you're going to be able to solve for both of those unknowns. If you're given one unknown, you're only going to need 1 point. If you're given 3 unknowns, they're going to give you 3 points, etc., etc. But you guys really only need to deal with 2 unknowns for the time being. The next question that we'll do after this, it might be slightly different, but we'll worry about that later. So let's actually substitute these 2 points in to see what we actually get out of it. So I'll firstly do 4 and -1, and then I'll do 8 and 1. Okay, so we have 2 equations there. So I might call this one number 1 and call this one number 2. So we're just going to do simultaneous equations here. You guys can do elimination if you want. You can do substitution. It doesn't matter. It's going to work either way. I'm going to decide to do elimination though, because I can see that we have just 1a here and 1a here as well. So we don't really need to do anything to these equations to make it so we're in a position to eliminate. So I might choose to do 2 minus 1, because that means I'm not going to have any negative b. So if I do 8b minus 4b, it's going to be a positive, and I prefer to work with positives. So that's what I'll do. And I'm doing that to eliminate a. And if I eliminate a, that should give me an answer for b, which will happen now. So if we look at 2, let's start with this bit here and this bit here. 1 minus negative 1, so 1 plus 1 is 2. Then let's look at the next section. A minus a, that's nothing. Then the last bit, 8b minus 4b is 4b. So b is going to have to be 1/2. So there's one of our answers. So we've got b, but we also need a. So let's take our answer for b, and we can substitute it into either one of these equations here, because we can see that if you fill in b, the only unknown you've got is a, so you'll be able to solve for it. If you fill in b, the only unknown you've got is a, so you'll be able to solve for it. As I said before, I like to work with positives, so I might substitute it into 2, but you get the same answer either way. And there we can see that b is -3. So there's that first one done. I'm going to move down to b of this question. Now what it's saying here is that if f of x equals 0, so f of x, that's the same as saying y, isn't it? So you could write this instead, if you wanted to, as y equals 0. So we're pretty much making y equals 0. Alright, so I'm going to get the rule that we had before, which was this one here, except we found out what a and b were, so I'm going to write the rule with the values actually in it. Okay, so there's our rule, and it's telling us that we want y to be equal to 0. Now, when we make y equals 0, we're finding the x-intercept, aren't we? So this is pretty much just another way of asking what the x-intercept is. Yeah, so let's make y equals 0 and then solve. Now I'll times this side by 2 to get it to 1x, which means I have to times that side by 2 as well. So x is going to end up being 6. There we go, done. Alright, so one more example for this exercise, which is this one here. Now, hopefully we can see that we've been given mapping notation here. So you've got your name of the function, which is f, you've got your domain, codomain, and our rule. We can see that our rule has a few unknowns, a, b, and c, and that's what we're being asked to find. So we need to find the value for a, value for b, and value for c. This can actually be done the exact same way as we did in this example here, except this one only had a and b. This one has a, b, and c, so it makes it seem a little bit harder. But what I'd like to do is just have a look at these 3 points that we've been given. So again, just like we did before, let's change them into coordinates just to make it maybe a little bit easier for us. You don't have to if you don't want to, if you can read it how it is. Right, now, these are actually special points. You're not going to be given special points every single time, but hopefully you can recognize that this, where x equals 0, y equals 2, that's a y-intercept. This one here, where x equals 4, y equals 0, that's an x-intercept. And this one over here, when x is 5, y is 0, that's another x-intercept. Alright, now let's look at our rule. They've told us that the y-intercept is 2. This part of our rule tells us what the y-intercept is, so we could actually change that to 2. So it would give us f of x equals ax squared plus bx plus 2, and you'll see that you've only got a and b to solve, so you can solve it the exact same way as what we did in that first example, or that earlier example. But because we've been given these special points, I'm going to do it in a slightly different way. So this is like our most general kind of rule for a parabola, or your general form. Hopefully you can remember there's a couple of other forms as well. So we've got turning point form, which would look like this. And we also have a factorized form, which would look like this. I'll use different letters, so it's not confusing because they're not really compatible if you use the same ones. Okay. Now, this one here, like we might be able to use that if we were told what the turning point was, but we weren't, so we're not going to worry about using that. This one here tells us about the x-intercepts though. So we can see that this part's going to tell us about an x-intercept. This part's going to tell us about an x-intercept as well. So I can pretty much grab these and put them into here and here. So that's what I'm going to do to start with. So E is just going to stay the same. And remember, when you put them in, you need to change the sign over. So it's not going to be x plus 4, it's going to be x minus 4, and the other one's going to be x minus 5. Okay, so we've pretty much subbed a couple of points in already, but we do still need to find out the value of E. Luckily we've been given that other point, which was the y-intercept, so you can substitute these two values in, and hopefully we're going to be able to find the value of E. So let's do that. Okay, so make your x is equal 0, your y is equal 2. So E is 1 on 10. So the rule that we have right now should look like this. The problem that we have at the moment is, see how the rule at the start, we had our A here, our B here, and our C here. Our rule doesn't really look like that at the moment because it's factorized. This is an expanded version. If we expand this out, it should look a lot like this one, and we'll be able to find what A, B, and C are. So that's what I'm going to do right now, expand it out. So firstly I'm going to use FOIL with these two, and then I'll apply my 1 on 10 to all the terms. Okay, so I'll use FOIL to expand that one. Now I need to times every term by 1 on 10. Oops. Okay, oh, that's not 20, that's 2. Okay, so let's look at both of these. Let's look at this rule here, and then this rule here. Hopefully, actually I'll write underneath just so it's a bit easier to see because the camera isn't getting it properly. if we kind of equate these two rules here, we can see what A, B, and C are, can't we? So A is going to be whatever's out in front of x squared. So A is going to be 110. 110. Our B is whatever's in front of x. So B is minus 9 on 10. And our C is going to be whatever the constant is at the end, the y-intercept, which we talked about before. And there we go. So we have just solved for A, B, and C. Now let's quickly look back at the question. All it told us to do was find what they were, wasn't it? It didn't necessarily say to show it in the rule. So we've done that. We've really clearly shown what A is, what B is, and what C is. So that's all I'm going to show you for, what is it? F. That's all I'm going to show you for F. You'll see the questions that I want you guys to do in the lesson plan. I'll really quickly just show you both of the pages that I've done, just so you can pause on it if you want to make sure you've got your own notes or whatever. So yeah, I'll just slowly go through so you can see everything again. Okay, so you can pause on any of that when you want. Make sure when you do the questions that you're posting your work on our notebook on Microsoft Teams. If you've got any questions as well, please post them in the correct spot, and I will get back to you as soon as I can, which will hopefully be pretty quick. Thanks guys, see ya.